Hello, everyone. Namaste and aloha. So, welcome to episode two of our series. Uh, like I had mentioned last time for episode one, that in episode two, we are going to focus primarily around mathematical principles in Bhagavatam and what we're calling it as from zero to infinity. So, in this, we're going to cover uh, the episode two. Are going to have again a multi-part episode, but the four key elements we're going to cover is first one is primarily bridging ancient and modern mathematics. So this is similar to episode one, comparing the mathematics which is in the ancient scriptures from a wisdom perspective and the modern maths. And then the second set of a group of uh, recordings we're going to do is going to be for the real world applications of what we're going to talk. And then the third component of this episode is going to be the 14 Vedic mathematical, what we call sutras, right? And then the last one on episode two, the last set of information is going to be on the different applications of, few of the sutras, not all the 14 sutras. So let's start, looking at, episode two and rightfully, titled Ancient Origins of Modern Mathematics, right? So it's actually bridging the ancient and the modern mathematics, right? And with the wisdom which is in Bhagavatam. So today we embark on an extraordinary journey, that will transform our understanding of mathematical history. So what I'm about to reveal, challenges everything we have been, taught about the origins of mathematical knowledge. For over 5,000 years, Srimad Bhagavatam, has been revered as one of the most profound spiritual texts of human history. But hidden within its verses lies something even more remarkable, right? One of the most sophisticated mathematical frameworks ever recorded. I'd given you a glimpse of it in my first episode. So let's digest that for a second there. Okay. So now, if you look at the timeline, the Bhagavatam was composed around 3000 BCE. So Aryabhata's mathematical works appeared around 500 CE, and Ramanujan's revolutionary discoveries came in 1900 CE, and modern mathematics continues to this day. But here's what truly is astounding. The Srimad Bhagavatam contains sophisticated mathematical concepts that predate modern discoveries by thousands of years, providing the foundation for many mathematical principles we use today. So, what are we talking about here, right? It's the decimal place value system with precise numerical systems, quantum time measurements with advanced calculations down to the atomic level, set theory and transfinity numbers, including the concepts of zero and infinity, fractal geometry and cosmic models with geometric principles of cosmic proportions. These aren't just symbols, what you see here, right? They represent revolutionary concepts that originated in ancient Vedic wisdom. The zero, the integral sign, infinity, pi, all of these have their roots in the mathematical understanding preserved in the Bhagavatam. Contemporary mathematics has rediscovered and validated many principles first described in the Bhagavatam, often with striking parallels in both concept and applications. And that's why we're also going to talk about both the concept side of comparison and the actual applications. Today we will explore these connections and discover how ancient wisdom continues to shape modern mathematical understanding. This isn't just history, it's a revelation that bridges the timeless with the contemporary, showing us that the greatest mathematical insights emerge when we honor both the ancient wisdom and the modern innovation. So, moving on, let's begin with perhaps the most fundamental mathematical system that governs our modern world, the decimal system and place value notation. That's what we're going to focus now. But this isn't just any decimal system. This is a sophisticated mathematical framework that was revolutionary for its times. You can remember, 5,000 years back. The Bhagavatam presents a sophisticated decimal place value system that was revolutionary for its times. Using powers of 10 to express large numbers with precision. In Canto 3, we're going to see later, Chapter 11, we find cosmic time calculations using decimal powers that demonstrates an understanding of mathematical notation that wouldn't appear elsewhere for thousands of years. Again, 5,000 years back. But here's what truly remarkable. The text introduces the concept of zero, or what we call in Sanskrit shunya, as both a placeholder and a number. This was a revolutionary concept that transformed mathematics forever. The time duration needed for the combination of those atoms is called a thruti, and 100 thrutis make one Veda. 3 Vedas make one lava. This is the quote from Srimad Bhagavatam, Canto 3, Chapter 11, verse 5. Just pay attention to the calculations which is expressed here, right? Notice the precision here. This isn't vague philosophical speculations. This is a systematic mathematical calculation using decimal relationship. The Bhagavatam describes numbers up to 10 to the 14th power. That's paradha, with specific names of each decimal level. Look at this progression, what you see here. Dasa koti, koti, laksha, sahasra, sata, dasa, each representing precise decimal powers. Now let's look at the modern section. Now look at the modern decimal system. The Hindu-Arabic numerical system with base 10 place values that we use today shares remarkable similarities with the system described earlier in the Bhagavatam, right? We use zero as both a number and a placeholder, exactly as described earlier, exactly as described in the ancient text. We use scientific notation for expressing very large numbers, just as the Bhagavatam did thousands of years ago, right? So the correspondence is striking. The ancient Sanskrit numeral, what you see here, right? 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 0, correspond directly to the modern 1, 2, 3, 4, 5, 0. The decimal powers, 10 to the power 9, 10 to the power 6, 10 to the power 3, 10 to the power 2, 10 to the power 1, 10 to the power 0 represent the same mathematical relationship described in ancient text. So let's look at one of the modern quotes here, right? As mathematics historian George Gergiswigis Joseph, right? George Joseph notes the development of the place value system with the concept of zero was one of the most significant achievements in the history of mathematics. But here's the revolutionary truth. The achievements didn't happen in medieval times. It happened thousands of years earlier in Vedic literature, right? The transmission path is clear. Vedic maths to Arabic transmission to modern mathematics, what you see here. Without this ancient foundation, we would have no modern mathematics, no computer science, no digital technology. Take time to digest that. Every calculation you perform, every digital device you use rests on this ancient Vedic foundation.